Today we're actually going to go over steep and shallow versus constant Z. Um, Usually with this, some users don't know which toolpath to use over the other when finishing maybe a 3D surface on the part. And today I'm going to try to get you guys understanding those strategies a little bit better. Um, a lot of you probably know, in PowerMill, you actually can do a lot of one thing multiple ways. So for example, this part that I created over here that you guys can probably see, I just randomly drew something together. And with this part right here, you can utilize a lot of the 3D finishing toolpaths and pretty much get the same result, but I will show you guys what these different toolpaths do better than the other. Um, so obviously I can't read your mind on how you guys do parts, but just so you know, at the end of this class, we are going to do a Q&A, and in the bottom left of the screen, you do have my direct phone number as well as my email address. So if you do have any questions on, maybe a part that you're working on, we can tackle that together. So the objectives I want to kind of go over is the explanation of strategies, the examples on sample parts that I created, and then we'll do a short Q&A. Depending on when we end, Q&A could be a little bit longer. If not, that's okay. We can always have you guys just contact me directly and I'll get with you on those questions. So, what is constant Z finishing? I'm sure you guys have kind of dabbled into the 3D finishing portion of PowerMill. Well, constant Z finishing, so this specific strategy creates a toolpath by slicing the model at specific Z heights. So this toolpath, you're really going to be focusing on those vertical surface, which require a constant depth of cut. So if you look at this part right here, you can see it's not really tackling the flats of it, but any surface that is more towards the vertical angle, it's kind of machining at a constant step over, or depth of cut, sorry. So that's what constant Z is. It's going to tackle those vertical surfaces. 3D offset finishing. So I did not mention 3D offset finishing earlier, but there's a reason why I'm bringing this up, because a different toolpath actually utilizes 3D offset finishing. So the 3D offset finishing creates a toolpath from a series of offsets starting at the outer boundary and offsetting towards the center, or vice versa. You can start from inside out or outside in. So this part that I created below, you can see it's kind of on a wavy area. I created those. If you're into motorcycles or dirt biking, we can call those whoops. So we have those right there. And I actually have a boundary around those surfaces, and it's creating a 3D offset finishing starting from the outside and offsetting in with a constant step over. So just remember that this is not ideal for vertical or near vertical surfaces. This is actually best for near horizontal or horizontal surfaces. So I would not compare it to offset flat finishing, but you can use this on complete flat surfaces. So just keep that in mind. Now, what is steep and shallow finishing? Steep and shallow finishing creates a constant Z toolpath in the steep regions. So what we saw before, we saw all those near vertical or vertical walls using a constant depth of cut. That was the constant Z toolpath. So it's going to utilize that toolpath on the steep regions of a model. And in the more shallow areas, it's going to be utilizing the 3D offset toolpath in shallow regions. So just kind of remember that. And you do see that it does say or raster. So in 3D offset, you can either do an offset setting in steep and shallow, or you can use 3D offset as 3D raster finishing. So we'll get to that later on. Now, what is optimized constant Z finishing? So we already know what constant Z finishing is. There's also an option called optimized constant Z finishing. This is obviously a separate strategy. So this actually creates a constant Z toolpath in the steep portions of a model and 3D offset only toolpath in the shallow portions, right? So keep that in mind. It's almost identical to the steep and shallow strategy. The only difference is that with optimized constant Z, you cannot specify when to change from 3D offset to constant Z. So inside of steep and shallow finishing toolpath settings, there's actually options that you can do to define when you want PowerMill to say, okay, we're going to go from 3D offset to steep and shallow. So there's a transition point, and that's really called the angle of threshold that you have, as well as you can set the the overlap on there. So optimized constancy is a good toolpath, or it is a good toolpath, but there are a little bit more features inside that steep and shallow strategy. So what we're going to do now is we're actually going to jump on over to the PowerMill side of things. So let me just change my screen over here. And right now we have this little square block that I created. It has a boss on the top and a pocket on the top. It almost could be like a male and female version of each other, as well as a main boss. So you got like that rectangle and then a tapered bottom portion. So the first thing I want to do, obviously, we want to create our block. So I'm going to create just a basic block on it. And let's see, I'm going to lock that minimum Z and expand it out by 100 thou. Because just remember, when you create your block, a lot of times toolpaths are utilizing the block as a boundary. So it's going to be looking for that block to machine on those surfaces. After that, I'm going to create my work plane. So we'll just create a work plane position on my block. And I'll activate that. And you can see it jump away from me. So I'm just going to change that coordinate system back to global transform and accept. So now we have our work plane. So the first thing I want to do is I actually want to create a constancy toolpath on the part, just so we know what we're working with. So I'm going to utilize this 1/2 inch end mill with a 60 thou radius. And in my favorites, I have constancy, so I'll select that. Just change that toolpath name to constancy. And usually what I like to do, guys, is good practice is just calculating the toolpath as is. Maybe make minor adjustments, but it's always nice to calculate the toolpath as is just to see what the outcome could be. So right now you can see that I have spiral checked, machine down to flats is checked, and then I have a step down of 0.02. We're also in inches, guys, so that'll be 20 thou. You can see right now that we're utilizing the work plane that we have. I'm actually going to turn off my transform work plane because that gets kind of annoying to me. And you can see that it's machining the majority of just the walls. You can see partially it's going to take over those fillets on the top edge, but for the most part, it's just tackling those walls of this part. What I do want to do is I'm going to go to Home, Toolpath Connections, and always remember, guys, when creating a toolpath for the first time or every time, just make sure that your safe area is always created and selected, because my planes are actually kind of high up right now. So I'm just going to calculate that and apply. So that's constancy. We can see that it's tackling the more of the wall versions or portions of this part itself. Next, what I want to do is I'm actually going to create a 3D offset toolpath on this part. So I'll close out of this toolpath, turn off my block because I don't need to see that anymore. I'll select 3D offset finishing. And with the same tool, we can kind of compare the two. It's always good to always double check your minimum and max. So I'm going to uncheck that. I was using that before. And let's see, step over, I'll do 20 thou and calculate. So you guys can see the difference right here already. 3D offset finishing is tackling really the whole part that it sees. It's utilizing the block. So it's using the block as almost a boundary, and it's kind of looking at the part and just trying to machine the whole part with this toolpath. If we look, it's not really a perfect toolpath because we can see that there's a start point. So like I mentioned with the kind of description of what 3D offset finishing is, it's going to start from the outside of the boundary and offset in. So you can see no matter what elevation you have of the specific model, it's going to start from the outside boundary and offset in. So we can see that the inner portion is either, it's kind of, PowerMill is kind of saying, okay, we're going to have an inner portion of the top of the boss and inside of that pocket. So that's where it's ending. So ideally, this is not a perfect toolpath for this situation. I would definitely use maybe like a steep and shallow, which we'll get to, or an optimized constant Z, because that's going to split apart the flats and the steep areas of the part. But I'll show you what this toolpath is really good for by itself. So what I can do is I'll jump on over to another part that I have. This is the goofy one that I created with steps and whoops, 2 pockets on the end. So I'm going to create a 3D offset finishing toolpath on these waves. And it's best used if you actually use a ball nose tool. So before we used a flat end mill with a radius, we'll take this 1/2 inch ball nose and we'll tackle these waves. So for just a 3D offset finishing toolpath, I'm going to create a boundary just utilizing those waves. So it's really best to create a boundary for this toolpath, because otherwise it's going to look at the whole part like you saw on the other project. So I selected those waves and I'm going to create my boundary now. So I'll create boundary, user defined. I always uncheck allow boundary to be private. I'll grab it from the model and I'll just name this one 3D offset. So after we have that boundary created, I'm going to create my block. And then what I'll probably do is I'll add 200 more thou to the top of the block. Press accept. Let's go ahead and make a work plane on the top of the block as well. And I'll activate that. All right. I'll go create my safe area because this is a new project. And now we'll open up that 3D offset finishing toolpath. Let's name this 3D offset. And what we're going to do is I'm actually going to give it a bigger step over just so you can see what it's actually doing. So I'll do 3/8 of an inch. I'll check spiral. And let's just leave it as is. Let me make sure there's no limits. We're good. Click calculate. Now, I always mention this to users. My personal pet peeve is always letting it start in the middle of the block. So I'm going to change that start point to first point safe, just because I like starting it right at that first point it wants to plunge. So you guys should see that it kind of tackles this toolpath by projecting an offset onto those surfaces. So this does a really good job of, near horizontal surfaces rather than more vertical surfaces. So what we can do is if we actually had this part in the machine and we had a nice step over of maybe 10 thou using this 1/2 inch tool, you can see that there is a cusp setting. So roughly 10 thou would be around 1/1000th of an inch cusp height, and I'll calculate. All right. So we can see that the toolpath created on this part is projecting onto those surfaces. And theoretically in the machine, this should give you a nice finish. You will obviously see where the corners start and it offsets in. You're going to have this little, these triangles, but that can always be buffed out or polished out of there. This toolpath can be used for some pockets. So not all the time, but sometimes this will be able to tackle pockets as well. So I'm going to close out of this toolpath. And remember, with this toolpath, it's always good to create boundaries with it. So the 3D offset finishing toolpath, it's always good to have boundaries with it. So what I'm going to do is I'm actually going to change the cursor selection tool to paint. And I'm just going to paint this front pocket, right? Now I'm going to create a new boundary, user defined. I'll just name this one pocket 1. Always uncheck allow boundary to be private, and I'll select model. So now I have a boundary around that pocket, and I'll do the same thing. So I'm going to select this other side. Create a new boundary, user defined, name this one pocket 2. Always uncheck allow boundary to be private, model, and accept. I'll just change that cursor selection tool back to box. And then what we can do is we can actually clone this 3D offset toolpath and then tackle these 2 pockets. So what I'll do is I'll right click, go to settings of the original 3D offset, and I'll clone. Next, I'm going to select the new limit boundary. So we'll go to pocket 1 first. Obviously, you want to make sure that your block is over the area that you want to machine. If it's not going to machine that area because PowerMill is going to look at it and say, hey, there's no material over there. I don't have to touch it. So just make sure that there's a block over the area. And for this example, let's just leave it as is. Actually, I'll change it back to about 1/4 inch step over just so you can see what it's doing. I'll click calculate. Now you can see with a 1/4 inch, it actually goes around starting from the outside and goes around that pocket, offsetting in a spiral motion. So with this toolpath, it's actually pretty good to utilize on some pockets, but not all pockets. So keep that in mind. More square pockets, it's really good for. But say if there was like a boss or a round pocket, it may not be ideal. What we can do is simulate from start and just kind of watch this move around. So if there was like a pocket on a part that you guys have maybe for a mold and you wanted to finish it, you could always utilize the 3D offset finishing toolpath because you're not going to have any weird retracts and it's just going to tackle it with one smooth spiral toolpath. Now we could do the same for this pocket, but you'll notice that there's a large flat in there. So depending, if you only have a ball nose tool, it would be fine. Let's go ahead and tackle this one. So I'll clone the toolpath again. Then I'm going to change that limit to pocket 2. I'll change that step over back to a 1/4 inch. But you'll notice that the stick out length is probably not ideal for it. So what are we at? About 3-inch stick out would probably be ideal. So I'm going to go and copy this toolpath, or sorry, copy the tool. I'm going to be crazy and change the flute length to 2 inches. Expand that shank, and then I'll do a stick out about 2.8. And then I'll calculate. So you can see that the 3D offset also does a pocket just fine that has maybe an upper corner fillet, lower fillet, as well as straight walls. So this toolpath itself is actually very versatile as for 3D finishing. So just always know that in PowerMill, a lot of ways to do one thing. So that's kind of what I wanted to show you about just this toolpath. So the 3D offset finishing, it's mainly good for those near horizontal surfaces, but you can tackle more of a square pocket with fillets or some 3D portions inside of it. So now that we know what 3D offset finishing is doing, I want us to jump back into the original file that we had open. So after seeing that 3D offset finishing toolpath, we're actually going to do a steep and shallow toolpath. So I'm going to just turn off that toolpath that we had active. And with the 1/2 inch end mill with the 60 thou radius, I'm going to open up steep and shallow. Now with steep and shallow, I'll just rename this one, you guessed it, steep and shallow. You have different settings inside of there. So like I mentioned before, with optimized constancy, which we have not gotten to yet, but you'll have a good idea of what it does, there's no options inside optimized constancy to change the threshold angle or the overlap between the two. So they're very similar tool paths, but steep and shallow allows you to change that threshold angle and change the steep shallow overlap. You also have separate settings for the steep areas and the shallow areas. By default, I'll just make sure my block is good to go. I will check spiral in steep and shallow. I want to climb in both directions. I don't want to blow up tools, so we'll just do climb. And we can do a step down of 0.02 and a step over of 0.02 as well. And like I mentioned before, for all the shallow areas, those more horizontal areas, you can select the type if you want to do 3D offset or raster. But we'll just leave it at 3D offset. Now what I'll do is I'll just click on calculate. Now you can see if I just turn off the block, and I'll actually modify my links because I did not reset those. We'll just go safe everywhere. Now the first thing that this toolpath wants to do is it's going to tackle those shallow areas. And what we'll do is I'll actually just simulate from start. So you can see it tackling, oh, is that the wrong one? Oh, that is the right one. Okay. I had a brain fart for a second. I was like, what is going on? So we'll tackle, and then it goes into the steep areas. So you can see it spiraling because what it's doing is it knows, hey, I checked spiral on both the shallow and steep. So it's going to try to spiral one toolpath as long as possible before it has to lift up. So this toolpath is obviously good if you have parts with a lot of 3D surfacing that may consist of pockets, flats, and fillets. So this part right here is pretty simple. So you'd actually be able to utilize this toolpath pretty well on it because it's going to tackle those shallow areas, those flats, into the fillets, into those steep areas. So we'll let this finish up for a second. All right. So the main thing that you may want to notice is that there is the threshold angle that you can adjust and the steep and shallow overlap. So if I just recycle this, and I'm going to clone. So I'm going to clone it because I'm going to make some changes in those threshold angles and the steep and shallow overlap dimensions. So really what that is the threshold angle is the point when the toolpath is going to change from 3D offset to constant Z. So always keep in mind that, the threshold angle, if you maximize that, it's going to stay in the constant Z longer. And if you loosen that up a little bit, it's not going to do the constant Z. It's not going to take those fillets of the, it's going to stay more flat, if that makes sense, which I'll do some examples. So threshold angles, the time it takes from when it wants to actually look at the 3D offset and change into constant Z. And the steep shallow overlap is the overlap between those two toolpaths. So right now there is no overlap, so it's going to, right when it stops doing a 3D offset, it's going to go straight into constant Z. If we had a 40 thou overlap, which we'll put, it's going to do a 3D offset to a certain point, and it's going to start the constant Z 40 thou above that last point of the 3D offset. So what we'll do is I'll just clone that, and I'll leave the threshold angle as default right now, but I'll do an overlap of 40 thou, and I'll calculate. So now you can see that there's an overlap, and if you just zoom in a little bit, there's an area where it's a little bit thicker. That's where you see the toolpath kind of change from 3D offset to constant Z. So I'll reset again, and then what I'll do is I'll change the threshold angle. I'll expand that maybe a little longer. And you can see that overlap adjusts a little bit towards the more bottom of that fillet. You'll be able to see this more if we actually change the shallow step over. So the cool thing about the steep and shallow finishing is since you can define the steep and shallow regions of what step overs you want, we can utilize that flat portion of the end mill. And maybe for this, we would actually do 125 thou step overs. So we'll utilize the bottom of that end mill. For all the flatter areas, we'll utilize that bigger step over. And then once it hits to that steep portion, we'll take that 20 thou and step down. So I'll click on calculate. And this is where you actually see that threshold angle. So the step over, when it was 20 thou, totally fine. You were good to go. But you can see with that threshold angle at 60, it's taking that 3D offset and it's expanding it further down, and you're utilizing almost more than you should. You want to shrink up that threshold angle actually a little bit. So what we can do is recycle, and let's do 20 thou or 20-degree threshold angle. And now you can see that it's starting that constancy earlier, closer to the top of that fillet. And by troubleshooting and just kind of going back and forth, you can just go and recycle that tool path until you get something that you're looking for. Next, what I want to show you guys is just the optimized constancy on this part. So we know how easy it is to modify settings within the steep and shallow, but for constancy, we'll find out that it's not as easy as that portion. So jump on over to optimized constancy. And also you'll see that optimized constancy is also spelt a little differently in PowerMill. So don't hate me. Usually it's a Z in the English dictionary, but it's a little different over here. So what I'll do is I'll just rename that optimized constant Z. I'll leave spiral checked. I'll leave closed offsets checked as well. So what that's going to do is it's going to try to create longer passes with the tool. It's going to have a lot less retracts. And let me just do _2. I had a toolpath in there that was named the same. And for step over, we'll leave that at 20 thou, and I'll just uncheck use separate shallow step over, because that is a thing you can do. But I'll uncheck that for now, and I'll click calculate. Now you can see that it creates a fine toolpath, but there's just less options that you can actually utilize. So with this kind of part, it may not be super ideal to use this toolpath on, just because you may want to adjust on when the step overs start. If we cloned it and we did check use separate shallow step over of 125 and click on calculate, we can see that this toolpath is creating a very similar toolpath as the steep and shallow, but you can't change on when you want that constancy to start. So if you did machine this in the machine, it might not be super ideal for all these fillets on the top. I'll zoom out a little bit and I'll just close this toolpath. Now I want to give you some examples on spiraling in the boss and pocket. So deactivate that toolpath, and we have the boss on the top, and we also have this pocket. So what I'm going to do is I'm actually going to go to the front view, change up my selection tool, and I will select that boss. I'll create a nice box or stock around this top boss right here, and I'll just change that to actually a cylinder. Calculate that, and then I'm just going to add 250 thou. So now we have, I don't want an expansion though, so no expansion. Okay, there we go. There it is. So now we have a little cylinder right over that boss. And the reason why I'm doing that is because I want PowerMill to just focus on that area of the part instead of having to maybe create a boundary or something. So I'm just going to focus on this area. I'll press accept. And the first thing I want to use is a constant Z. So let's go to constant Z. And we'll name this one boss constant Z. I'll leave it spiral. I'm just going to uncheck machine down to flats. And we'll leave the step down of 20 thou. Click on calculate. So remember with constant Z, it's really going to try to just tackle those areas where it's more towards the vertical surface. So if a surface is more on the vertical end, that's what it's going to tackle. It's not going to tackle anything that's flat, even though that I have my stock expanded way past that flat. So there's plenty of room for that tool to go. It's just going to look at the vertical surfaces or near vertical surfaces of the part. So the constant Z, really good at doing parts with steeper surfaces or walls that you want to finish without really messing with that floor or a flat surface. I'll close out of this and I'll actually create a toolpath using the 3D offset on this boss. So we can rename this one 3D offset boss. I'll leave it as spiral. We can leave the step over of 20 thou. And outside in, yeah, we can click on calculate. Now you can see something goofy going on. If we're doing a 3D offset on here, you guys can see that it's still kind of utilizing the corners of whatever it's looking at. So it's taking a boundary and it's almost creating corners of that boundary and offsetting it. So it's not going to really look much at just the boss to say, hey, I can spiral in a nice smooth radius. It's tackling it in a way that you may not think is ideal for this specific part. So this is kind of showing you that the 3D offset, although it may be good for those pockets that we saw on the other part, it may not be good for, round bosses or round pockets like this. This would actually do the same thing in the pocket to the right. So in this right pocket, you would actually get a toolpath very similar, but obviously doing the inner pocket. So I would suggest really not to tackle, a boss or round pocket with a 3D offset finishing toolpath. Lastly, I do want to show you the Optimize Constant Z toolpath on this boss. So we'll jump on over to Optimize Constant Z. And we'll just name this one Opt Constant Z. And we'll just type in boss at the end of there. Leave spiral checked, close offsets, obviously making PowerMill say, hey, let's make a really long pass if we could. Step over of 2, and I'll just uncheck use separate shallow step over, and I'll click calculate. Now what I'm also going to do is I'm going to say, hey, avoid this flat area. So I'm going to recycle the toolpath, go to limit, and Z limit. Let's go ahead and I'm going to pick this top surface and I'll just say plus 5 thou. Let's do plus 5 thou again. Which I could just say, hey, I'll probably just delete it. So you can see that it's still trying to tackle these flats with the optimized constant Z, which I really don't want. So what I'll do is, oh, that's why. Let's bring it up. That's what I don't want it to do. So with something like this is where we can utilize maybe a boundary just to get rid of all these kind of odd jumping moves, right? But I would normally just kind of turn off the model, look at it from the top, turn off the tool, and then I'll just select what I don't want. Just around the part. And this, guys, is the cool thing about PowerMill is because you can easily modify the tool paths by right-clicking, going over Edit, Delete Selected Components. You can see it over there. You can also go to the Toolpath Edit tab in the ribbon bar and click on Delete Selected. So we turn the model back on, and now we have a clean spiraling toolpath for that boss. So that was a little more work than we wanted. You can, limit it to a boundary just to make that portion easier, but that's no big deal. You can just easily delete those out of there. So with that being said, I'm gonna actually go shoot on over to this right side pocket, and I'm gonna use the optimize constant Z again, go to settings, and I'm gonna clone it. So I just wanna clone it because I wanna utilize the same settings. And that error was just telling me, hey, you made edits, it's not gonna be there next time. I'm totally fine with that. I'm gonna create my new block. So we'll create the new block in this pocket. And I'll just expand the top a little bit. And this limit, I don't want the toolpath to start above this surface. So I'm gonna do a max just under that surface. So we'll do negative 10 thou starting at the top of that surface. And I'll click calculate. So you can see that there's this toolpath spiraling in from the top, going in. What I can do right now, I can just turn off that. And we do have a little bit of a break right here. I can just right click, go to edit, delete selected. And if we just turn on the tool again, simulate from start, you can see it tackle that pocket just fine. So really the best uses of the optimized constant Z, it's really good for finishing bosses or pockets with fillets. That's really what I use it to tackle. So I used to, if I had a lot of dowel pin holes and I wanted to utilize a 3D toolpath, instead of actually having a reamer because maybe I couldn't get one in time and I don't feel like using a swarf toolpath to just use the side of an end mill because maybe there's taper, I would actually use the optimized constant Z quite a bit. Steep and shallow, really good with doing parts that have a lot of 3D surfacing that may consist of pockets, flats, and fillets. So like this whole part in general, good for that, steep and shallow. Right? Also with 3D offset, always remember areas that are not perfectly flat, near horizontal surfaces sometimes works. It also sometimes works with square pockets with the fillets, but it is best for the near horizontal surfaces that are not perfectly flat. You can tackle completely flat surfaces if you have maybe a ball nose. So always remember 3D offset finishing, utilize that ball nose. This is not if the surface is flat. Toolpath with not flat surface, just like the wave or the whoops over here. If you did utilize this toolpath with maybe a bull nose end mill, it won't machine the way you want it to. And constant C toolpath, that's good with parts with steeper surfaces or walls that you want to just finish without really messing with that floor. So, it could be almost any of these features on this part right here, more towards the wall portion of it. So really, constant Z, good for more of a wall type surface or a model that has a lot of walls on it or near vertical portions. And Dan is asking, is there a way to have different lead in and lead outs in the shallow part of a steep and shallow toolpath? So we have a steep and shallow toolpath, and he's looking to say, hey, on your shallow areas, can you have a different lead in, lead out than in those maybe steep areas? So normally with that, since this is one toolpath, if we were to do a lead in, lead out, it's going to do that lead in and lead out for the complete toolpath itself. So normally after completing a toolpath, I'll just jump into the home tab and then click on toolpath connections. And that's where you obviously can change your lead in lead outs. If we were to just look inside the steep and shallow finishing toolpath, and we go to lead ins or leads and links, there is no really way to specify, hey, when it's doing the steep areas, I want this lead in, lead out. When it's doing the shallow areas, I want this lead in, lead out. If you really want to specify sometimes things like that, you would actually have to select the areas that you want to maybe have different. So in PowerMill, it's obviously a really good program because you can actually specify specifically on which areas you want to do a certain lead in and lead out. So for this example, I'm actually going to select this area that has a lead in, lead out, or that has a lead in, and maybe I want it to, let's do a horizontal arc with an angle of 90 and a radius of 125. Shoot that on over to the lead outs. Actually, I'll just apply the lead outs and lead ins. This I want to have none. So really, if you want to specify, you would actually have to individually select the portions of the toolpath that you want to have different around the whole part. Andrew asked, what additional stock and flat tolerance do in constant Z? So I'm going to click accept and I'm going to go to the constant Z. Let's go to the settings. And we're going to look, and I'm just going to recycle this. And there was, let's see, there's additional stock and flat tolerance. So additional stock, another nice thing about PowerMill is it does a really good job of explaining things kind of if you hover over something. So it gives you a quick tip. You can see right here, additional stock. Hover over right there. It's the estimate of thickness of a stock to remove. This is used only to determine the safe order. So it's really really looking at it as, okay, there's if you're looking at say plus 25 of additional stock, that's determining the safe order of how it's going to order that specific toolpath, if that makes sense. So we can also hold or click on this question mark, select that box, and it brings us a help menu to, oh, that didn't do it too. That was not ideal. Let me click on that again. There it is. Gives you an example of what exactly the additional stock is right there. So it's really just there to determine on the safe order of your constancy strategy. So if you do want more in-depth explanations of different areas on any toolpath or any portion of PowerMill, anytime that a window has this question mark up there, you can click on it, puts a question mark on your cursor, then you select the detailed area that you want to know more about, and then it'll shoot you on over to a portion on the Autodesk side of things with more details. Now, Lawrence is asking, can you control plunge rates? So that is really determined by the speeds and feeds portion. So obviously you'd be changing your plunge rate in there. Lawrence, as for your question, controlling plunge rates, is that, does that answer the question, or would it be plunge rates between steep versus shallow? Because normally, okay, so Lawrence is asking, between the steep and shallow, can you control those plunge rates? In PowerMill, no. it's always just based on the tool. So if we go over to a tool right here, I'm going to go right click and go to settings of a tool path or a tool itself. Go on over to the cutting data, and I'm going to uncheck hide empty rows. So you can see that in the cutting data, there's a type column, operation column, and then all your details about speeds and feeds. So this is where you can actually modify your speeds and feeds. Obviously, I'm sure a lot of you guys know that this is a location to specifically change the tool's speeds and feed settings. In the toolpath itself for steep and shallow, I would suggest just to have your plunge rate to be suitable for maybe plunging into a good amount of stock in case that's what you have to do. If plunging is an issue, I would always just slow down your plunge rate, obviously, and just kind of utilize that. Obviously, when you're doing steep and shallow, you're using a toolpath for finishing only. So normally, it shouldn't be an issue to plunge a little bit because you'll normally be plunging into maybe 5, 10, 15, up to 30 thou of stocks. So I know it could be more aggressive material. And if it is aggressive material, what you always can do is we can jump on over to steep and shallow. And for this example, I'll leave everything deselected, go to toolpath connections, and that's when you change your lead-ins and lead-outs. Probably just your lead-ins for your plunging. So let me just delete everything. So lead-ins, you can do vertical arcs or something like that. And maybe we'll do an angle of 90, radius of 60. And that would create a vertical arc on all your lead-ins to kind of gradually throw that into the part. You could do a ramp, and we'll do a zig angle of maybe 3, follow a circle. Let's do 0.5. You could do ramps in all the areas that you may be plunging. So since you can't define the plunging on steep versus shallow, I would just suggest changing your lead-ins to gradually push that tool into the material.